All right, let's put on our architect hats for a minute. Imagine you're running one of the biggest online stores on the planet. What's the one thing that keeps you up at night? It's probably this: selling the last pair of sneakers to two different people on two different continents at the exact same time. Yeah, that's a disaster. So today, we're going to build the solution. We're going to figure out how to keep that data perfectly in sync no matter what. Let's get into it.
So here's the game plan. We'll start with the problem itself, the global inventory challenge. Then we'll get to a huge fork in the road, synchronous versus asynchronous replication. After that, I'll lay out the actual multi-cloud blueprint, the solution. From there, we got to stress test it, right? So we'll tackle those inevitable data conflicts. And finally, we'll wrap up by figuring out how to monitor the whole thing to make sure it's all running smoothly.
Okay, first things first. Let's ground all this in a problem that's super real, one that basically powers the global economy and that you and I deal with all the time: online shopping.
You know, this isn't just a thought experiment. This is the multi-million-dollar question. And it's not just two people. We're talking about thousands of people, all at once, all over the world, hitting different servers on different clouds. And they all need to see the one true number for how many sneakers are left. If you get this wrong, you're selling stuff you don't actually have. And that's not just a lost sale. You've just lost a customer's trust. The stakes, they're huge.
So, our mission is crystal clear. We need one single source of truth, a single golden record for our inventory that every single system agrees on, and it has to update in like the blink of an eye. That's the goal. Now, how do we actually build it?
To even start building this thing, we have to make a choice. It's really the cornerstone of any distributed data system, and it's a decision that's going to shape everything else we do. We need to talk about replication. Just think of it as making perfect copies. Simple, right? When a sale happens in one location, we have to copy that new inventory number and send it out to all of our other databases around the globe. But how, and more importantly, when we make that copy? Well, that's probably the biggest decision we're going to make.
Okay, so this is where we hit our first major decision. It's a classic trade-off. With synchronous or sync replication, you're being super careful. You don't tell the customer their purchase is complete until every single database in the world confirms it has the new inventory count. It's absolutely consistent, but man, is it slow. I mean, the speed of light is a real bottleneck here. Then there's asynchronous or async. This one's the speed demon. It tells the customer success as soon as the local database is updated, and then it sends the update to everyone else in the background. It's wicked fast for the user, but, and there's always a but, it introduces this tiny window where the databases might be out of sync. For our global sneaker store, though, speed is the name of the game. So, we're going with asynchronous.
All right, so we've made our choice. We're going async. Now we can actually start putting the pieces together. So here it is, the architectural blueprint for how this is all going to work.
So yeah, this is our high-level plan. And notice, we're deliberately using multiple clouds. That's not just to have backups. It's so we can get our data physically closer to our customers, wherever they are in the world. This whole design is about speed and global reach.
And this just lays out the data flow perfectly. Okay, so a customer in the US buys the sneaker. That transaction hits our main database, AWS Aurora in North America. Instantly, that change gets published to something like a messaging system. Think of it like a data bus. Our other cloud providers are listening in on that bus. So the new inventory count gets replicated to Azure's Cosmos DB in Europe and to Google Cloud Spanner over in Asia. And that right there is the core pattern. One primary spot for all the writes, the actual purchase, and many replicated spots for all the reads, people just browsing the inventory. It's how we get both consistency and that incredible speed.
But what happens when our super fast system creates a problem? What if two people in totally different parts of the world try to buy that last sneaker at the exact same moment?
This is it, the ultimate stress test. We've got one sneaker left. Someone in London clicks buy, and their request shoots off to the Azure database in Europe. At the same time, someone in Tokyo clicks buy, and their request goes to the Google Cloud database in Asia. But remember our architecture? Neither of those is our primary write database. So, who gets the sneaker?
Well, the solution here is actually pretty elegant. We use business logic. See, in our blueprint, all purchase requests, no matter where they come from, get routed to our one primary database in AWS. It literally becomes a race. The first request, whether it's from London or Tokyo, to hit AWS Aurora and lock the database row for that sneaker, wins. The second request, it arrives a few milliseconds too late, sees the inventory is now 0, and gets rejected. It's fast, it's fair, and it's decisive. Problem solved.
Okay, so we've built the system. It's fast, it's resilient, it's smart.
But as an architect, your job is never really over, is it? A system like this is a living, breathing thing. Now we have to watch it. We have to monitor it.
You know the saying, you can't manage what you don't measure. So we need a dashboard with all the vital signs of our system. We're going to track transaction throughput to see where the traffic is coming from, and use data consistency checks to make sure no data is getting garbled along the way. But out of all these metrics, the one that matters most, the one we're obsessed with, is replication lag. That's that tiny delay between the primary database getting updated and all the replicas catching up.
And this right here, this is our North Star. We need that lag to be under 1 second, always. This single number tells us if we're actually delivering on our promise of a near real-time global inventory. It's the difference between a happy customer and a very, very frustrated one.
At the end of the day, that's what this is really all about. This whole complex architecture, all these clouds and databases, it's not just tech for tech's sake. It's about building trust. It's a promise we're making to every single customer, no matter where they are, that we'll give them an experience that is fast, accurate, and totally reliable.
So that kind of leaves us with a cool question to think about. As the underlying tech just keeps getting better and better, will this whole process of managing replication just disappear? Will it become a solved problem? Something totally handled by the cloud providers themselves, making the architect's job even more high level. It's a pretty interesting future to think about. Thanks for exploring this with me today.